Hello everybody. So I wanted to actually work a few of these with you. Just to kind of show you what it looks like when you start simplifying these. So let's start here. We have the product of x to the fourth and x squared raised to the power of 3. Right, so we have this being multiplied by that, and then this grand total being raised by 3. So we can do a little bit of PEMDAS work, if you will, and start out with our parentheses. So the base is the same, and they're being multiplied. So that means that this 4 gets added to that 2, giving us x to the 6 cubed. Now, whenever we have a power being raised to another power, we multiply. So, pretty simple. We should take that 6 and that 3, and we multiply them together. 6 and 3 is 18, so your grand total is x to the 18. And that is it. So this whole thing simplified is x to the 18. There we go. Okay, let's look at another one. Is that the same one? Yeah, okay, it's the same one 2 times. Here's one that I was having a hard time getting to format, so I just wrote it out by hand, rather by mouse, on my computer and took a picture of it. So we have the quotient, because we're dividing, the quotient of x to the 5th and x squared raised to the power of -4. So this one's totally different because we're dividing and there's a negative sign. So let me show you how to do this. When dividing, we just subtract, right? So this base is the same as that base. So these are subtracted. 5 minus 2 is 3. So we have x cubed raised to the power of -4. Now this step should look just like this step, right? Where we have them being raised to each other, so we multiply. Well, we just do that again. So 3 times -4 is -12. So we have x to the -12. But we're not really done, because we don't like negative exponents. So what we need to do is flip it. So remember, this is over 1. So now we put this 1 up here, that down there. And we get 1 over x to the positive 12th, right? Because if you flip it, you get to make it positive. So that's the final answer. Let me circle that for you. 1 over x to the 12th. And that's that. That's all we're doing. Let's look at another one. Now, admittedly, this one is a little harder, right? Because now we have negatives. So what I want you to do is pause the video, work this out as much as you possibly can, and then once you've done as much as you can, unpause, okay? So go ahead and pause now. Okay, hopefully you paused that. Hopefully you did as much as you could. First thing we check is the bases. X and X, we're good to go. So this can be simplified. Whenever we're dividing, we subtract. So we do -3 minus -2, right? Like that. But whenever we minus a negative, we bloop bloop. Right now it's plus a positive. So -3 plus 2 is -1. So we have x to the -1 being raised by the -3rd power. These guys get multiplied together, A negative times a negative is a positive, so -1 times -3 is +3. So it's just x cubed. And that's it. That's all there is to it. And that is done. So hopefully you found that helpful. You know, I think I could invent one more question, just real quick. So if we had x to the 4th plus, or not plus, we're not adding. Oh, it's not letting me select that. I don't like that multiplication symbol. I'll just do big dot. Times x to the 3rd to the -1st power, right? Okay, so here we're multiplying, which means that those get added. 4 plus 3 is 7. X to the 7 raised to the -1. And please forgive my mouse writing. I know that it's not the best. Sorry. So that's a 7. Those get multiplied together. 7 times -1 is -7. So we have x to the -7. But we're not done because we don't like negative exponents. So we flip it. 1 over positive x to the 7th. You know, I really don't feel like exponents are hard. You just have to remember, if you're multiplying with the same base, you add them. If you're dividing by the same base, you subtract them. And if you're raising it to another power, you multiply them. As long as you can get that, you will do absolutely fine on the exit ticket. Hopefully this was helpful. Have a fantastic day. Thank you for watching.